10-5 hyperbolas including foci. I've drawn two hyperbolas, one opening side to side and one opening up and down. The side to side hyperbola, this one would have x first in the equation, and the up and down one would have y first in the equation. We have a couple new things, but lots of old stuff. The dashed lines are actually not part of the graph. They are the asymptotes. We would find the center, which is where the two asymptotes meet. Then underneath the first denominator is the distance from the center to the vertex here. So that distance is going to be underneath the first denominator. Then the conjugate radius, it's some sort of a distance this way that helps us figure out the asymptotes, is going to be underneath the second denominator. So that we'll call b. Then the distance from center to focus, just like in parabolas, we're going to have something called a focus that's always on the inside. That distance is always going to be the c. And this will follow the a squared plus b squared equals c squared of the Pythagorean theorem. The same thing works for an up and down parabola. The distance between the center, where the two asymptotes meet, and the vertex, that distance is going to be like an a value. That's underneath the first denominator. Then the conjugate axis, radius, not the full distance of it, but just the radius of it, is going to be under the second denominator. And then the distance from the center all the way to the focus, that would be the c. Kind of like the hypotenuse, and a squared plus b squared equals c squared. The vertices, remember, we need to be thinking about slope, and remember that slope has rise over run, and so that's going to be the y over the x of the radii. So whatever the y radius over whatever the x radius, that would give you the asymptote equation.